Hello everyone, welcome to my YouTube channel. I am Kasunia Maya. Today I am going to teach you what is linear data structure and examples for linear data structure. Let's go start. First we are going to learn what is a linear data structure. The linear data structures are a type of data structure in computer science where data elements are arranged sequentially or linearly. Each element has a previous and next adjacent except for the first and last element. When we talking about characteristics of linear data structure, we can mention sequential organization. It means in linear data structures, data elements are arranged sequentially, one after the other. Each element has a unique procedure and a unique successor. Next one is order preservation. The order in which elements are added to the data structure is preserved. This means that the first element added will be the first one to be accessed or removed, and the last element added will be the last one to be accessed or removed. Actually, linear data structure can divide into two sectors, that's a static data structure and dynamic data structure. According to static data structure, there is a example is array, and for dynamic data structure we can get examples as stack, queues and linked list. Let's learn about static data structure and dynamic data structure deeply. Now we are going to learn about what is static data structure. When before learning static data structures or arrays, first we have a simple idea of what is a static data structure. So now we are going to learn what is a static data structure. In static data structure, the size of the structure is fixed. The content of the data structure can be modified but without changing the memory space allocated to it. We can change the content of the data, but we can't change the memory space allocated to it. You can get a simple idea for this example. I have added a simple examples for static data structure. In previous slide, we talk about arrays examples for static data structure. Now we are going to learn about arrays. Actually, what is an array? An array is a collection of items of the same variable type that are stored at contiguous memory locations. It is one of the most popular and simple data structures and is often used to implement other data structures. Each item in an array is indexed starting with 0. Each element in array is accessed through its index. Now we are going to talk about need of array data structures. Actually, arrays are fundamental data structure in computer science. They are used in a wide variety of applications, including storing data for processing, implementing data structures such as stacks and queues, presenting data in tables and matrices, creating dynamic data structures such as linked list and trees. When talking about types of arrays, there are two types of array. First one is one-dimensional array. These arrays store a single row of elements. Next one is multi-dimensional arrays. These arrays store multiple rows of elements. I have included one picture of in previous slides. You can go and visit examples for one-dimensional arrays and multi-dimensional arrays. Now we are going to talk about applications of array. I have included some three or four applications of array. They are storing data for processing, implementing data structures such as stacks and queues, representing data in tables and matrices, creating dynamic data structures such as linked list, and there are so many applications of arrays. In linear data structure, we have divided it into two sectors, that are static data structure and dynamic data structure. In previous slides, we talk about what is static data structures and what examples for static data structures. Now we are going to talk about dynamic data structures. First, we should have a clear idea of what is dynamic data structures. And do you think what is dynamic data structure? In dynamic data structure, the size of the structure is not fixed and can be modified during the operations performed on it. Dynamic data structures are designed to facilitate change of data structures in the runtime. When we talking about static data structure vs dynamic data structure, static data structures such as arrays have a fixed size and are allocated and compile time. This means that their memory size cannot be changed during the program execution. Index-based access to elements is fast and efficient since the address of the element is known. And dynamic data structure, on the other hand, we have a variable size and are allocated at runtime. This means that their memory size can be changed during program execution. Memory can be dynamically allocated or delocated during program execution. Due to this dynamic nature, accessing dynamic based on index may be slower as it may require memory allocation. Stacks is the one example for dynamic data structure. Stack is a data structure that can hold many elements. Here I have included two examples for stacks. Let's get started to learn what is stacks and how to implement these stacks. And especially these stacks also be known as LIFO queues. It means last in first out queues. Let's learn what is LIFO queue. Now we are going to talk about stack models. There are three models in a stack. They are push, top and pop. Push means input an item to a stack. Pop means access the top item. Pop means delete the top item. When we push a item to a stack, in a stack last pushed item is the top. That is the top item. When we implementing a stack, we should know stack operations. In here, I have mentioned stack operations. First one is clear. It means clear the stack. Second one is push. Push means add an element to the top of a stack. Pop means remove an element from the top of a stack. Peek means get the value of the top element without removing it. Is empty, check if the stack is empty. Is full, check if the stack is full. When we implementing a stack, we should know stack properties. First one is the last item added to the stack is placed on the top and is easily accessible. Stack is the appropriate if we accept to access on the top item, all other items are inaccessible. Now we are going to learn about Java implementation for stacks. Let's get started. Here I have mentioned how to implement a stack using deque. I know all of you can learn Java. I have coded this by using Eclipse. In this I have mentioned check if the stack is empty, check if the stack is full, and add elements into stack. That means push operations. And by studying this code you can get a simple idea of how to implementing stack. I hope all you guys have get an idea about what is linear data structure, what are the two types of linear data structure, and what is an array, what is a stack. And in next video we are going to talk about how to implement stack deeply and how to use stacks, why we want stack, and last in first out method we talk about in deeply. Thank you so much. Please subscribe and click on the bell icon for get all notifications of my YouTube channel.